In this lesson, we're going to be using trig ratios to solve right triangles. So let's talk a little bit about what it means to solve a right triangle. Well, in a right triangle, as you know, your right triangle is made up of the two legs and the hypotenuse. The hypotenuse is always opposite of the right angle. And in order to use the Pythagorean theorem, we said that you have to know about at least two of the side lengths. If you know two of the side lengths, you can use the Pythagorean theorem to find the third side length. But the Pythagorean theorem does not tell us anything about the angle measures. All we know is that these two angle measures are going to add to 90 degrees, and that's it. So the Pythagorean theorem helps us find the third side if we know two of the sides. Special right triangles are useful to help us find all three sides, but we have to know about one of the sides of the right triangle, and we have to know their angle measures. And that only works with 45, 45, 90, and 30, 60, 90s. So to solve a right triangle means to find the lengths of all three of the sides and to be able to find all three of the angle measures. And that's going to be able to be found if you're given two things about the triangle. And so in order to be able to find that, we use what is called the trig ratios, the sine, cosine, and tangent ratio. So what are the trig ratios? Well, the trig ratios are three different ratios used to find missing sides or angles of a right triangle. Now, when we do that, we're going to first off have to label our right triangle in a certain way. So it's no longer going to be leg, leg, hypotenuse. So the first thing we have to know is we have to have an angle of reference. So in this triangle, I'm going to let angle A be my angle of reference. You're going to have one of the two angles that is not the right triangle that will be your angle of reference. So angle A is my angle of reference. And I'm going to label all of the sides of this right triangle according to this angle. So my hypotenuse, that's never going to change. That's always going to be the longest side of the right triangle opposite of the right angle. But the other two sides are now going to be labeled opposite and adjacent. This side right here is the side that's not touching the angle, and it's going to be opposite. So this side is opposite of angle A, so it's going to be my opposite side, whereas this side right here, the side touching or that makes this angle, is adjacent. Now that we know how to label our sides of our right triangle, now we're going to set up our ratios. So the first one is sine. Sine A. So when you write your ratio, you write which one you're talking about, and then always following it is the angle measure. So sine A is always going to be equal to opposite over hypotenuse. So sine is the length of the opposite side over the length of the hypotenuse. Next is cosine A. Cosine A, if we use cosine A, we have to use the ratio that is adjacent over hypotenuse. And then the last trig ratio is tangent. Tangent A is always going to be equal to opposite over adjacent. These three ratios are the ratios that you just have to memorize. There's some things in math that we memorize, like the quadratic formula, and this is one of them. So there is a useful way to help you memorize this, and it's the old wise Indian. So ka, toa. So how do I use this mnemonic device? The S stands for sine. The O is for opposite, and the H is for hypotenuse. So sine is opposite over hypotenuse. Ka, so the C stands for cosine. The A is for adjacent, and the H is for hypotenuse. And then tangent, so toa, T is for tangent, O is for opposite, and A is for adjacent. We get in the habit of even calling it SOHCAHTOA because we use it that way so much. But SO, sine, opposite over hypotenuse. Ka, cosine is adjacent over hypotenuse. TOA, tangent is opposite over adjacent.